Hello, everyone, and thanks for joining us here today at let's talk about enterprise, about event-driven architecture, and both Christian and I are kind of very passionate about the messaging, enterprise integration. It's our background. So we thought it would be great to kind of have a short overview of what it means to do event-driven architecture in the modern day with all the things that are available, things like microservices, data streaming, cloud-native platforms, functions. So that's what we're going to do today. And we're going to get started. Just a quick introduction. My name is Maris Bogovici. I'm Chief Architect for Red Hat. I work in data streaming and event-driven microservices. And I hand it over to Christian.
My name is Christian Posta. I will be the co-presenter. I'm also Chief Architect at Red Hat. I work with a lot of our customers in North America to help them understand what microservices, cloud, DevOps, all that hype, buzzword stuff really means and how they can get value from it. So what we're going to talk about today is going to roughly follow this path. We're going to look at what event-driven architectures, what that is. We'll look at why you might want to do that, what it looks like when you do actually implement that, and some of the value that you would see both technically and from a business perspective that you would see from that. And then we'll start to look through some of the different forces at play when we start to implement this with the infrastructure that we've used in the past, from messaging systems to integration hubs and so on, and how cloud has kind of changed this dynamic, and once we get to microservices and functions, how those play in this type of architecture. Does that sound okay? Is that why you guys came? All right. So before we get going, I want to set a couple. I want to make explicit what some of these forces are when we talk about building cloud-native architectures, building systems that we have in the past, and the forces that we've had to solve for. There's three of them that readily come to mind. One of them is agility. So I'm sure you've been hearing this quite a bit. Agility, how do we adapt to our systems? How do we respond to market forces? And unfortunately, no one can predict the future. Can anyone in here predict the future? I'm still looking for that person. So what we end up trying to do is run experiments and try to learn more about what our customers would find value in. And we want to build our organization and build our system to be able to run experiments cheaply and learn from that. And change course when we find that we might be going down the wrong path. So this is the agility part. The opposite end of agility is high and extreme optimization for a single purpose, right? You're building a machine with all of its components intertwined specifically for that one purpose. It's very difficult to change that. The second force we'll look at is efficiency of the resources and the way we use the resources that we have. So going from trying to eliminate waste in our build, deployment, operational pipelines, and get extreme high utilization of those resources. The third one is the ability to understand what the system is doing. All the way from very simple systems, which are you can't build complex systems with complex parts. You want simple parts, but as you start to build up and get more complex, you don't want to go off into chaos. Right? So these are three lenses through which we'll try to look at some of the historic things we've done in terms of building applications, getting them to talk to each other, and how cloud has introduced some new paradigms for us.
And in order to understand how things build up and how we actually bring this agility, this optimized utilization, this simplicity into our architecture, I think we want to start our journey into the event-driven architecture. We're actually looking at events and how to build and design application with events. And why do we like event-driven architecture? It's kind of a silly question whether it's like, what is it? Is it a universal panacea? No. It is, however, I mean, it would be ridiculous to believe that, right? But it is, for us, it is a solution to technical challenges, for solving business complexity, and as I said, to bring it this agility, utilization, and clarity, which is like simplicity that also kind of allows you to describe things in an expressive, understandable way. So where do we start, right? And the starting point is the notion of event. Is this idea that certain interactions, like request reply, for example, are simple, are very simple to describe, but at the same time, they have some characteristics that make them fragile. The fact that the interactions are ephemeral. Like if the client or server dies, then you basically kind of have lost the interaction. There's no way to pick that up. They're highly coupled. Both systems have to be on at the same time. They're not very composable. Like if you always have system A talk to system B, it's hard, for example, to add another system into the mix without creating a more complex structure. So this point-to-point communication actually makes it hard to integrate those things. Overall, there is this low tolerance to failure also that makes it hard to be the foundation of a distributed system. In contrast, we have event-driven interaction, right, which essentially is posited on like having producers interacting with consumers and introducing a separate entity, which is the event that describes the interaction. And that somehow survives it being produced by the producer, and it might survive even being consumed by the consumer in certain types of publish-subscribe interaction. But the fact that these systems actually do not necessarily know about each other's existence. The producer just produces events, the consumer just consumes them from a separate source, make them very decoupled, highly composable. And there are trade-offs. It's a more complex model, but what you get for that is higher tolerance to failure. Events come in all shapes and forms. They can basically, an event essentially describes an action or an occurrence, something that happened in the past, something that's immutable, something that others can react to. There are different flavors of events. They can be notifications, for example. They can also be what's called state transfer or command, where a component actually indicates that an action needs to be taken in response to that. And they're part of data synchronization. They can be part of a data synchronization model, like event sourcing and CQRS. So if you really want to drill down on these different types of events, I strongly recommend Martin Fowler's article on the different event types, where we got this breakdown. Now, establishing that the event is centric to our application design kind of leads us to the next step and say, well, how do we design systems around them? And this is where the notion of event-driven architecture comes from. Taking an event-centric approach in system design, treating the events as part of your domain model, and basically designing components as separate entities, very decoupled, that react to events and produce events. Right? And the nice part is that this is very aligned with advanced domain modeling techniques, like domain-driven design. If you describe your bounding context as how many of you are familiar with domain-driven design and the notion of a bounded context? Well, that's a good show. So you can appreciate that if you describe your bounded context and you describe your external actions that happen to your bounded context as events, and you describe how they influence your domain objects, then event-driven design comes as a natural companion to that. And then, obviously, it also creates a ubiquitous language, right? This is kind of it's a bit small, but let me try to drill down a little bit into this. You see, I'm having this diagram here describing an interaction between different services, orders, billing, shipment, inventory, and I'm pretty sure that some of you might object that the model is accurate. But what is important to me, like I like about this diagram, is that if I look at it, I understand the flow of events. I understand what happens because I can look and say, an order gets created, then it gets paid, then it gets shipped, and so on and so forth. So events create a ubiquitous language that you can describe your system in. And finally, event-driven architecture creates highly observable and extendable systems. So, for example, I can add another component in here that listens to those events, and I can essentially extend this this system in much further. There are techniques like event storming that are worth mentioning here that take the link between domain-driven design and events much further and actually start with events first. Like you just think of your system completely in terms of events and design for that. And then your domain basically is kind of a function of your event structure. And furthermore, and this is something that's to think about, events are not only a vehicle to deliver better systems, they're also a way of better modeling your business because, the world is event-driven. Like if you think of everything that happened to you today until you came here and even after you joined us, everything is an event, right? You came in, a door opened, you entered the room, you sat down. Everything are these small, very small transactions, very small interactions that we use to actually describe and understand the world around us. And we affect change on the world around us, which is perceived as events by other actors and act accordingly. So it's a very natural model for the business. And the other aspect that drives event-driven models into business modeling is agility and experimentation. So essentially, understanding, like moving from, let's say, storing data and kind of having a very static view of the world as much as you can to understanding the processes that are happening and understanding basically the change as it happens. And this is something that's for example, very specific for IoT. We have devices and events, and then you react to them and you construct, you kind of interpret that as actions. And that becomes very important for your business, right? The other corollary to this is that these events, treating events as first-class citizens, allows you to take a bottom-up approach. You collect all the events. Not all your events, not the smallest occurrences are actually relevant to your business, but you can start designing new events by analyzing what happened, by having a good understanding of all the interactions in the outside world. So you see this with things like clicks and monitoring, for example, the location of a vehicle or something like that, where the events themselves are not treated individually, but they're lumped together, right? And this has been a tenet, for example, of complex event processing for a long time, in which you kind of know up front what a sequence really means. But you have other techniques, like machine learning, where you can infer by observing the sequences what they actually mean. So that's something to think about, and that kind of reinforces the importance of thinking in events first as part of your business design. And in summary, the point that we were trying to drill down here is that we really like this topic of event-driven architecture. We really advocate for it because it reduces friction. It reduces friction from a technical standpoint because it allows you to build robust and resilient distributed architectures. It reduces friction from a development process standpoint because it allows you to be agile. It allows you to replace components with new versions. It allows you to introduce new components into your topology. And finally, from a business standpoint, it is very aligned with how the world works, and it helps you model the world better, right? So in order to see how that happens in practice, in order to see what the middleware is, how it works, I think it's going to be good to take a look at how the middleware has evolved to actually drill with the uninterrupted flow of events.
So the way we would actually implement this, and Marius gave a good overview of what the event-driven architectures look like, but how you actually go about implementing this. In the past, what we saw was using messaging middleware to help facilitate the delivery of these events. And we did this through different interaction models, queuing, pub/sub. Subscribers would listen to these messages. If they were not there, they might miss some of the messages unless we did persistent messaging, which then, if they unsubscribed or if they left the talking with the broker for a little bit, those messages would be saved for them, and so on. And we saw this set of technology kind of crop up to solve that kind of problem. The messaging brokers like the JMS messaging brokers, AMQP-based messaging brokers, like ActiveMQ and others. And the way we would deploy that is we would have a broker through which all of the messages would flow. And this broker was responsible for queuing, point-to-point type messaging, pub/sub messaging, persistent messaging, keeping track of what consumers were available, and so on. We would have multiple different types of throughput requirements, latency requirements, and this one broker, this logical broker, became kind of a bottleneck for this type of thing. We did that on purpose, though. We wanted high utilization of our middleware, and we wanted high utilization of our infrastructure. And so the more we could jam into this central messaging platform, the better we would get our utilization rates up. But that reduced some of our agility. Marius mentioned the type of events that might flow through this system, things like business domain events, higher level business activity events. And now we're met with challenges of, well, we want to know more about what our users are doing. We want to track their individual clicks on the website. When we unroll new features, we want to understand why they clicked here and not over here. We want to go back and do different analytics on this. So the way our messaging infrastructure has evolved is to deal with this type of complexity. So we've tried to maybe distribute out the messaging infrastructure a little bit more to account for this. But once we take this orders of magnitude higher, where now we're talking about millions, tens, hundreds of millions of events a day, maybe more, billions, this core centralized messaging infrastructure for these types of use cases doesn't fit as nicely. What we want to do, just kind of like we did with the relational database, where we said, we have this highly optimized use case. We want to decentralize and rethink the way we implement the data store into more very purpose-built engines like the NoSQL style databases. We want to think about doing that similar thing with our messaging infrastructure. And that's where projects like Apache Kafka and others built on much simpler constructs and help decentralize the processing of these messages out to the individual services that are using them. That gives us the ability to scale horizontally more, reduces the amount of coordination that we need between the broker infrastructure, and allows the clients to come and go without detrimentally impacting the performance of the broker. So we end up with architectures that start to fit a cloud platform a little nicer, with this much simpler infrastructure in place, and the producers and the consumers taking on more burden of getting the messages from one place to the other. And that's why projects like Apache Kafka and Strimzy.io. So Strimzy is a open source community to help bring Kafka to a cloud-native platform like Kubernetes. But that's why these platforms are ideally and purpose-built for this, this collection and distribution of large numbers of events.
And to continue to what Christian said about the infrastructure, like the next logical step is to look how traditional event-driven architectures like enterprise application integration have actually fared, and what are the options? What are the modern options for doing application integration in with everything that we have today, right? This type of new brokers, and actually even cloud architectures. And in order to understand that, it's good to understand the evolution happening in the enterprise integration world, right? The evolution from, the first step in the evolution from, from enterprise service buses, very, kind of all one-stop shop, basically, for integration, tightly integrated, tightly coupled, constructs that have basically been the kind of the initial approach in doing this. And they had a few goals. One of them is basically kind of building on top of this messaging infrastructure and sort of adding more and more features that allow you to higher and higher level constructs inside a runtime to handle things like routing, transformation, mediation, right? Kind of making that part of the platform. Running applications, almost acting as application servers. And that at the time was a good thing in a way, because utilization was the most important thing. Cost was the most important thing. You wanted to optimize cost by packing as much functionality you could into a deployable unit, into a runtime, and try to jam that together because it was super expensive to get new machines. So you couldn't even think about distributing things or running things in separation. One of the problems with this was the mix of, the inevitable mix of logic and infrastructure that happens. And eventually, the applications themselves became tightly coupled, starting to know too much about the platform and about each other. And this has led to a kind of a movement where I'm trying to refine this. For one thing, this type of thing on the left is not very agile. It's pretty hard to apply modern things like test-driven development, like CI/CD, deploy new components easily without starting an entire platform. Nobody wants to do that. I really want to work on isolated development units. We want to work self-contained. We want to be agile. We want to have that breakdown. And this has led to a different model of enterprise integration, which has been made possible by frameworks like Apache Camel, where the responsibilities are divided better between components. You have standalone applications using general purpose messaging, so nothing beyond the normal functionality of a messaging system in between, and deferring functionality like transformation, mediation, and everything else into the applications themselves, because you know what, they're better suited, the developers understand better the business logic, and it's easier to change and modify and adapt them. And that was great. And it works. But the advent of cloud-native platforms have made possible a more evolved model that allows us to recapture some of the utilization benefits on running on a platform. And this is basically what you see on the right? This notion that you can have discrete applications, containerized, like in this case, Camel applications, interacting with services provided by the platform. So even the messaging, even the data services, everything you have in there is essentially provided by a service on the platform, right? In this case, OpenShift, right? So you have things like Unmask, for example, for running messaging as a service. You have Streamzy for running Kafka on OpenShift. And you have OpenShift as a platform to help you run these containerized applications. What does it mean for, in terms of, what does it mean for this integration model? What does it bring to microservices? Well, enterprise integration is a big body of knowledge. How many of you are familiar with the Enterprise Integration Patterns book? That's great. That's a good show of hands. So you can appreciate that these patterns have been put in the context of creating wholesale solutions out of siloed components, siloed enterprise systems, connecting mainframes to other systems, and so on. There is nothing specific to that in them. They're effectively patterns for event-driven architectures, for interconnecting event-driven solutions. So we see that they are applicable to general purpose event-driven interaction. And effectively, they're very well suited for building what we call building event-driven distributed systems, or as you know them as a more on the pet name of event-driven microservices. For example, again, coming back to Apache Camel, right? There's an entire set of examples that you can take and look how that works. Incorporating the streaming aspect in this essentially requires you to rethink, let's say, messaging and rethink how data flows to your system. Not only think about individual messages, but think about streams as continuous, unbounded data flows that your application can connect to, right? And again, we see the same pattern, and again, we see the same benefit of using small services working together to process and interpret a large number of streams, right? The other angle where this is, where data streaming helps in integration solutions is using eventual consistency as a data synchronization pattern, right? How many of you are using batch processes, for example, to bring different data stores in sync? That's typical. The batch processes and in fact, batch processes are a very good tool for specific use cases. But in some other scenarios, for example, when you want to have this propagation in real time, you want this continuous flow of updates to move from one system to another, from one microservice to another, from one database to another. So in that context, combining this, the data streaming and applying these techniques like event sourcing and, as I said, eventual consistency on top of stream-oriented messaging systems like Kafka, for example, or even Kinesis or Azure Event Hubs, if you're trying to do that, gets you to that point, right? And of course, you also need to rethink the way you do this integration. So again, coming back to the notion of small services working together, the frameworks, instead of thinking of big, large-scale compute clusters, which have their place. For intense computations, they're great, but there are certain types of scenarios where you basically want to have access, want to update, want to control different parts of the pipeline. You want to scale them independently. So in those types of solutions, data pipelines built of small services working together, built using frameworks like Camel, Kafka Streams, or other frameworks, for example, can help you get there. So that's a change. There's a shift in the mindset. And it comes back to this idea that modern integration is agile, decentralized, and targeted to cloud-native platforms, right? So that's pretty cool. We have built a model. But there is a next step, and I'll let Christian talk about that.
So far, what we've looked at was events and event-driven architectures as a foundation for building our applications. We looked at some of the concrete implementations using messaging infrastructure and how that's evolved to help meet this growing need for this and idea of building the applications this way. Then we also explored how that tied in with integration and how the different forces between the utilization and how we force things into centralized hubs versus agility, and now we're starting to optimize a little bit more for agility, and we're starting to build the services that have the integration capabilities and the stream processing capabilities into the services themselves. We start to go toward a microservices style architecture, and microservices specifically is the ability to build these autonomous components that are independently deployable and allow parallelization of work between the teams. So it's as much, if not more, the technology as it is about the way the teams interact with each other and how they own the different components and different services in the system. Now, these autonomous components relate, again, very, very nicely to the more abstract notion of how we interact with each other, right? We are all individually autonomous components, and we interact with each other through events. And so event-driven microservices is a very natural architectural approach. Now, with a services architecture, we can break apart the system according to business domain, according to how the teams interact with each other, but also in terms of technical constraints, like certain parts of the system are very I/O intensive, or certain parts of the system have higher security requirements, and so forth. So we're going to end up with a large collection of these services that we then need to be able to manage and deploy. Excuse me. And that's where containerization starts to come into the picture. So with containers, I'm sure I'll ask for a raise of hands, but I'm sure people have heard of containers here at this Red Hat event. Okay. So containers help to bring this ideal of microservices and agility into balance with, well, how do we actually take these services, of which in the past we might have had them run on VMs, especially if you're building Java applications. Java applications kind of expect that they're on their own VM. That's kind of how you tune it. So you would have this proliferation of events, and the utilization of your infrastructure drops. So with containers, we try to bring that back into balance here. We want to reduce the overhead of running these services. So we want to eliminate having a separate operating system for each one of our instances. We want to package the application in such a way that is portable across infrastructure deployment platforms. We want to increase the utilization of the physical or virtual infrastructure that we have. And so what we end up with is better utilization, and we still retain the agility that we're looking for as well. So microservices is we've been talking about it for 4 years now. Even the same principle at the application level, from the SOA days. So it's been around for a while, but it's becoming a reality with the cloud infrastructure that's now very readily available. But what is your use case? You should always stop and ask yourself, what am I optimizing for? What use case do I really have? Microservices are great at enabling agility and introducing agility where it has started to become a bottleneck in the application architecture. And if you look at any of the successful examples of microservices, the Amazons, the Netflixes, and so on, they all started with a big, hairy, complex system, a monolith. And the boundaries that they introduced and the way they went about carving up those services, they were able to understand that because they had this existing system, and they were able to go back and use that prior knowledge. If you're starting off from the standpoint of exploring business use cases or exploring possibilities for innovation, you don't have that knowledge of what the boundaries should be. So you don't over-optimize an application architecture at that point. So some of these use cases, the exploratory use cases where you're coming up with hypotheses, putting things out in front of customers and gauging response. You don't want to sink a massive amount of investment into that because you don't know if that's going to be a viable business. So you're doing lots of MVPs. A lot of them you're throwing away. If you do get something that does provide some value and you're starting to see interest from customers, the usage patterns are going to be very unpredictable and even unknown, and maybe even spike if you actually find something that worked out pretty good. So these exploratory use cases, trying to over-optimize the architecture for microservices and to try to somehow sink massive investments in terms of capacity planning for this is kind of you're trying to put the cart before the horse. There's also other use cases where you have services that you knew ahead of time, and they are kind of I'm calling them the under-utilization use cases, where you have an app, maybe an HR app or something that's up, and people only use it on Friday, let's say. It's only used maybe 8 hours out of the week. So having a set of services around to always serve that traffic when when the traffic is kind of wasted utilization as well. Another use case of this is where you need massive amounts of computing power and parallelization for a very short period of time. Obviously, cloud workloads, the availability of cloud and being able to procure this massive amount of infrastructure is available. But we're going to start to look at streaming use cases, batch file, large file processing use cases, and so forth that make it a lot easier to do this in a serverless or function-style environment, which we'll talk about. And then lastly, use cases around kind of bespoke or one-off type integration. Setting up scheduled jobs, running webhooks or one-off webhooks for callbacks, reacting to database changes, and some basic stream processing, and we'll come back to that. But so that's where function as a service starts to fit into the picture. It's pay as you go, pay for at the millisecond what you actually use. It's on demand and event driven by nature. So you can start experimenting. You can go there and start experimenting with your different business use cases very quick by focusing only on the functions and the code that you actually have to write, not procuring infrastructure, capacity planning, architecture, application architecture, which you might end up throwing all away anyway. And in a function as a service implementation, you write the code, and all of the stuff underneath the yellow line, is handled for you by the platform provider. So all the containers and OSs and VMs and all that stuff, you don't as a developer deal with that. And in this model, where you pay as you go and you pay for the usage, that you get very high utilization rates, even higher than containers. So another look at this is your functions run in a landscape where developers, the user experience for the developers is deploy these small sections of code. Down here is the serverless aspect. Well, you can see all the servers here. Is the serverless aspects where you don't really know what the topology is. All you do is deploy your code and get charged for the time that you use it. And so serverless can be applied to both functions as well as other things like databases like Amazon Aurora and those where you're paying just for the time that you're using the databases. Now, I started off this section by saying understand your use case. When to use microservices when you have well understood boundaries and you know what those boundaries are, versus when you might have exploratory use cases where the traffic patterns and spikiness of the workload and even business case, you might not even know if this provides any value. You don't want to optimize for that by building a big system. Different options that you have in this cloud-native landscape with event-driven architectures. You can run your containers as microservices on-prem or in the cloud. You can also run as individual functions when it makes sense to do so. Any other thoughts that you have?
Well, I think the important part, I think that's the kind of where we wanted to take this discussion here is you start thinking and kind of giving a little bit of putting this into a bigger picture. You start thinking with events. You start designing your applications around events. You start having, once you get there, you have all these options that Christian just went to. What you want is to encourage decomposition, to encourage thinking in small, replaceable, decoupled units of work. And event-driven architecture encourages you to do that. In the end, there is this, obviously this ongoing debate about microservices versus functions. Which one is better? Which one should I use? Which one? We would like you not to think of them as it's an evolution in the sense that one is better than the other. So if you're at the microservice stage, you're obviously not as advanced as the cool kids, which are the serverless stage. That's not how it works. You have to think in terms of them being both facets of very deep, of a design strategy that encourages decomposition, that focuses on the cloud-native aspects of the platform. And based on the different things that you have seen, like based on whether you're experimenting or whether you have low usage, or based on whether they're kind of these what we call limited integration use cases, right? You have to pick up one or the other. And what you want, and this is kind of a guideline, is to design your services and to think in terms of, you want to basically kind of throw away as little work as you can. You want to have this kind of, you want to pick tools and frameworks that enable you to easily kind of move from one deployment model to another. Because in the end, and this is something to bear in mind, especially about the utilization process, a lot of the use cases is in serverless. Like serverless itself adds some overhead inherently. Like every optimization, every way, like everything that happens in a dynamic way adds some overhead. You want to, like microservices are less flexible. So what matters for you if you have a predictable use case pattern, if you understand, like if you have a high number of transactions, for instance, then the cost of invoking functions at, like, I don't know, when you do 1 million transactions per second is going to be very high, whether you run it in Amazon or you run it locally, like whether you pay for it or you're going to have a lot of resource utilization just turning the functions to actually do the work. So that's basically where you have to think about, like what kind of utilization model, what kind of use case I'm looking at.
All right, well, thank you for coming to our talk. Are there any questions that we can try to answer?